Hey Algebra 2, in this video we're going to be talking about operations with polynomials, which are actually pretty straightforward and intuitive. So first of all, let's define a couple polynomials. If f of x equals 4 minus 5x, so degree 1 polynomial, and g of x equals 2x squared plus 3x minus 2, find or determine the following. So first example, let's do f of x plus g of x. So you're going to start with turning this into an equation. So this is going to equal, and you write your whole f of x function plus your whole g of x function. Like in the last chapter with complex numbers, you need to be careful if this is subtraction, so you remember to distribute it. But in this case, we don't need to, so we can just get rid of our parentheses. And combine like terms, but because this is a polynomial, we need to make sure we write it in the correct order. So I'm going to start with 2x squared. And if you want, you could like cross it out to remember that you already did it. So then negative 5x plus 3x, we can combine these. So negative 5 plus 3. So we have negative 2x. And 4 minus 2. And that's it. Here is the equation of our new polynomial, which is the same as f of x plus g of x. Alright, let's do another example. And we could give you other problems that are more challenging, like the polynomials are larger. I'm just giving you a linear polynomial and a quadratic polynomial. Let's do f of x minus 2g of x. So again, we're going to start with replacing these with a function. So this is f of x, so we have 4 minus 5x minus 2, and then times the g of x. So now the first thing we need to do is distribute this 2. And then I always recommend showing the distribution. So first let me bring this down. So 4 minus 5x, negative 2 times 2x squared will be negative 4x squared. And then we need to multiply negative 2 times 3x, so negative 6x, and negative 2 times negative 2, which is positive 4. And now we're kind of like we were up here, where we're going to combine like terms and make sure we put it in the appropriate order. So negative 4x squared is the highest degree, so that will be our leading term. Negative 5 minus 6, negative 11. And then 4 plus 4. And there's our new polynomial. Alright, let's do some multiplying. So that's adding and kind of subtracting, but with also multiplication. So what if I gave you f of x times g of x? Notice that I'm not using an x for multiplication. Some of you guys are losing points for that. So again, put them in parentheses first. So we have 4 minus 5x. And then g of x, so times g of x, which is 2x squared. And this is where you FOIL. And we've got more than 2 terms, so just be extra careful. It's very easy to mess up. So we need to do, right, 4 times 2x squared. I'm going to move this down just so I have room for all my arrows. So 4 times 2x squared will be 8x squared. 4 times 3x is 12x. 4 times negative 2. And then same with this negative 5. So negative 5 times 2 will be negative 10. And then x times x squared will be x cubed. Then we have negative 5x times positive 3x, so negative 15x squared. And finally, negative 5x times negative 2, so positive 10x. Alright, and we rearrange and combine like terms. So our leading term will be cubed, right? Negative 10x cubed. And 8x squared minus 15x squared. Was that negative 7x squared? Then we have 12x and 10x, and they're both positive, so that'll be 22x. And I'm left with minus 8. Alright, let's do one more example and then we'll call it good. Let's do g of x squared. So you could write that a couple ways. You could put it in brackets just because you can map this whole function to the second power. It could also be in parentheses. So that's we're going to take our g of x function, which is, this is going to be a doozy, 2x squared plus 3x minus 2, and then we're going to square it. So the first thing we need to do is expand this, right? This being squared is this whole thing times itself. I hope everyone's watching this video. This is a good problem. And then, just like the last example, got a lot of formulating to do, but it's even more because this is 3 terms and this also has 3 terms. So brace yourselves for a lot of multiplying. Hopefully I don't make any silly mistakes. So 2x squared times 2x squared is 4x to the 4th. And then we have 2x squared times 3x, so that's 6x cubed. 2x squared times negative 2, negative 4x squared. Okay, now these 3, oh gosh, this is going to look crazy confusing after. So 3x times 2x squared will be positive 6x cubed. 3x times 3x will be 9x squared. And 3x times negative 2 will be negative 6x. And then I'll just do another color, I guess, since we still have one more term, that's this 2. So negative 2 times 2x squared will be negative 4x squared. Negative 2 times 3x. And then negative 2 times negative 2 will be positive 4. Oof! Okay, so now we rewrite, and again, be careful, it's easy to mess up. So our biggest one is cubed, oh no, 4x to the 4th. Okay, and then I have a 6x cubed, a 6x cubed. If you wanted to, you could even highlight. So I have 6x cubed plus 6x cubed, so that's going to be 12x cubed. I have negative 4x squared plus 9x squared. And then minus 4x squared. So that will be positive 1. So it's just going to be x squared, right? So I have negative 4 plus 9. So 5. And then 5 minus 4. Okay, so I'm recording this late and I'm tired. Okay, and then we have negative 6x minus 6x. And then positive 4. And there ain't no more. Alright, so just a couple of things. First of all, hopefully everyone watched this video, so you are familiar with work. But notice I always substitute, right? I've got an equal sign the whole time because this is what it's equal to. I'm combining like terms, right? So biggest thing is like, are you showing work? Is it legible? Right? Are you writing things in order? Okay, take your time and just be careful. But that's it. Operations with polynomials, they can get pretty messy, especially when these are bigger polynomials. But that's it.